It's Saxon Algebra 1, Lesson 79. It's going to be a good one, you guys. I hope you're excited. I know you are. I can see your faces. I can see your smiling, shining faces in my imagination, and it powers me on. We're talking today about systems of equations, and you're like, yeah, we know systems of equations. We've been doing that. Substitution, elimination, it's not a big deal. Here comes the add-on with something called subscripted variables. Okay, a subscripted variable, let's say that we chose x and we put a little 1 by it. This is called the subscript. It's just another little letter or number that helps us distinguish between our variables. So a subscript doesn't change anything about the way you do the math. It's just, I would say. It's decoration, you guys. You can handle a little decoration. No big deal. Now, the first example, gives us a series of equations, and I'm not sure you guys have seen this exact array before. So let me write it all out, and you can get a headache just looking at it. And I won't talk until I get it all written. Well, I just did, but you know what I mean. Okay, we have 4 equations here. 1, 2, 3, 4. John usually writes them across the page like this. I often will write them down to show you all 4 at once. In either case, they'll almost always be presented in this order. Notice that this has 1, 2, 3, 4 variables. We're using the letter R twice, and we're using the letter T twice. And notice they have these subscripts, A, P, and P. These come from story problems that involve rate and time. And so that's what the R stands for. The P are different people in the story who are doing things. So this could be the rate of Anne, the time of Anne, the rate of Paul, the time of Paul. I'm making that up, but you see what I mean. So the letters help us match the equations to the story, and later you're going to be like, okay, so maybe this is not just a ridiculous headache. Maybe this is helpful after all. So notice that this equation has 4 variables, and then 3 of them make a reappearance in the other equations. We should have an S on it, I just noticed. Abby's probably, haven't you, Abby? So these just are numbers that equal some of the variables. This is what we call the base equation, because what we're going to do is we're going to use this as the base, and we're going to, in systems of equations, we often substitute. We're going to substitute these into the base. All right? I draw arrows, but it would just turn into a big mess. This one will go in here. This one will go in there. This one will go in there. So we start with the base equation, and we make buckets. You know how I feel about a good bucket. Okay? So now I've changed all of the variables into buckets, and now I'm going to plug in what I can, and we're going to have 1 left over, aren't we? It wouldn't be any fun if we didn't have 1 left over. So it happens that it's the first one that we don't have a number for, but the time of Anne, using my little story that I made up in my head, the rate of Paul, that's 50. The time of Paul is 4. Okay? Now it just becomes, I was going to say a horse race, but that, I don't know if that conjures up the right metaphor in your head. Now we're to something very familiar. We can solve this without any drama. So this would be 200. This would be 3 times RA. So we can subtract 200. And we get 3 times the rate of Anne. This is all gone. Equals 120. Divide by 3. And we get that the rate of Anne equals 40. and that's the final answer. So, the takeaway I want you to have from this little chat we've just had is that number one, I gave you a number. They're little letters or numbers that hang at the bottom of a, not at the top like an exponent, down at the bottom. And they help us match the variables to the story. They're called subscripts, and they don't change the math at all. The other takeaway I want you to have is this pattern of 4 equations where the first one has a bunch of variables. We use that as the base, and then we plug things in and solve. Yay, it's fun. Let's do another one. Example 79.2. Let's look ahead. There's 4 of these. Holy smokes. All right, let's just keep charging on. So here come the 4 equations. This time I'm going to write them in a list. John has them going across the page, but I don't want to make my page look really crowded. John, to my knowledge, always puts the base equation first. You can daydream while I write this. Okay, so again, I'm just going down instead of across. The base equation is still first. The base equation is the one that has all the variables in it. Now notice that this one looks a little different. Before we had clump of variables plus clump of variables equals number. This time we've got the number in the middle and the clump over here. What does it change? Not really anything. For our purposes, when we get into the story part of this later, you'll understand the circumstances in which we do this. But right now it just takes shape, but we still have this pattern where we have 3 more equations that simply set one of the variables equal to a number. So we're going to approach it the very same way. I'm going to copy that equation, the base equation, carefully so I don't change it at all. Okay, RT goes in the first block, that's 2. TT, they're equal. What I like to do when the 2 times are equal is just take off the subscripts and make it a plain T. Because if they're equal to each other, then we don't need to have the subscripts to distinguish them. So I'm going to put a T here. Plus 120 equals RR is 10. And then TR, again, we change that to just plain T. So now we have 2T plus 120 equals 10T. And now we're back onto solid ground. We'll subtract the 2T. 120 equals 8T. Divide them both by 8, and I'm pretty sure that's 15, right? 10 times 8 is 80. No. Oh, I'm dividing. I was multiplying in my head. 10 equals 80, and then we would have 40 left over. 8 times 5 equals 40, so 15 is our answer. Okay? And what were we asked to find? That's always a good question to ask yourselves, guys. Is what are we trying to find? Solve the following system: R and TT. So we calculated that T equals 15, and then we know that the 2 T's are equal to each other. So I'm just going to add it like this. Okay, so our answer is 15. Yay. Another page. Another problem. Example 79.3. Oh, Gracie just groaned in her sleep. Okay, this one has a third shape. And these are L's and S's. Notice that the little clumps of R's and T's that we multiply, they have matching letters. That's going to be the case for all of these problems. And here come the little baby equations that help us out. Oh, and look what's going on with our T's this time. TS equals TL minus 5. Okay, that's a little different. but our process is the same. Base equation comes first. It has all four variables. We set up the buckets for that. RL equals 40. TL, we don't have anything, so we just use plain TL, right? We don't have anything that defines TL. That's our missing one. RS equals, and TS equals TL minus 5. Now that may make you a little bit nervous because that is way more messy than what we plugged in before. But look, now we have two TL variables, so we'll still be able to solve this. It'll be fine. So don't let this frighten you. Just plug it in like anything else and trust the algebra to do the heavy lifting. 40 TL equals, and now here we're distributing, 80 TL minus 5. Oh, wrong. 400. Right? I forgot to distribute. But I caught myself, so it's all good. I'm going to live dangerously. I'm going to let these guys hang negative, and I'm going to subtract the 80 TL from both sides. Just feeling so bold this morning. This will be minus 40 TL equals, that's all gone, minus 400. What? Thank you, John. So TL equals, okay, so these cancel each other. It becomes positive. Those go away. I'm dividing each top and bottom by 10. Now I know 4 goes into 40 10 times. So my final answer is that TL equals 10. Now, John wants me to find TL and TS, okay? So now I have to go back here. TS equals TL minus 5, so that would be 10 minus 5. So TS equals 5. There's my first answer, there's my second answer, okay? So there's another wrinkle, kind of like we saw in the last problem. Sometimes you have two things you have to find. So make sure that you're reading the question and finding out what John wants you to do. And I always recommend to my students, once you get an answer, that's the time to go back into the book and look and see if you've answered the question. You look at it at the beginning, but you know what? You always forget by the end because you've got a million other things on your mind. Then when you get to the end, look back at the question and say, oh, wait, did I answer the question? And then you'll know. Okay, one more, and then we're done with this lesson. Example 79.4. Solve the following T and RE. Wait. F and E. Sorry. I got my first eye lasered the other day, and they literally shot lasers into my head like 40 times. It was wild. But when she looked at my eye, she said, "How do you even see?" And she said, "I don't understand how you." And I said, "Right? Not well." Okay. RFTF equals RETE. But I hope by now you would agree with me that even if I copied the letters wrong out of the book, the math is exactly the same. I would just have the wrong letters. It wouldn't change the numbers at all. But that's just needlessly confusing. TF equals 16. TE equals 12. And RE equals RF plus 15. Okay, so this one kind of looks like the last one where we have value. One value is related to the other by adding. I think was subtracting, but kind of the same idea. So, again, we know how to do this. We just have a different combination of things to plug in. This is our base equation. Again, John put it first, but even if he mixed it in, we would know it because it has all the variables in it. RF, we don't have, so we just use RF for that one because that's the fourth one that we don't have. TF is 16. RE is now this chunky thing, and TE is 12. Plugging in straightforward. This confuses me a little bit because it's a backwards distribution, so I'm going to be careful and get my little hoochajiggies going in the backwards direction so I don't mess that up. This, I want to change the order of 16 RF, that feels better to me than RF 16, equals 12 RF plus, okay, let's just do 15 times 12. 2 times 5 is 10, 3, 15, 180, plus 180. Okay, let's subtract this, so we'll get positive numbers, and we have a minimum of swimming. That goes away. 4 RF equals 180. We divide by 4. This is what my brain does. I know that half of 180 would be 90, but I need to cut it in fourths, so I would chop 90 in half again, and so I would get our F equals 45. Does that make sense? Chop it in half once to divide by 2, chop that in half again to divide by 4, so 90, 45. Okay, I have an answer. Let's see what John wants. He says solve it for RF and RE. Okay, so there's my equation for RE. So RE equals RF plus 16, so that, or 15 rather, sorry. I said that because I know that the answer is 60 and the 6 came out of my mouth to say 16 instead of 15. See the problems I have? RE equals 60, and I'll just put a box around all of that because I'm happy with my answer. Is it right? Yes, it is. All of our answers were right. I was checking them, but I wasn't marking them as right. Okay, that is lesson 79. That is how we use subscripts. I'll write it here again. Subscripts in a system of equations. They don't hurt a bit. It's fine. Good luck in your homework.